Is it really that big of a deal if you forget plus c when you do an integral? The answer is yes. So here's an example where, depending on the method of integration that you use, you will get different values of that plus c, okay? So in other words, without the plus c, you will have two different answers that are different from each other depending on how you do this. So let's go straight in. We've got the integral of 1 over kx dx, and just for simplicity, let's just keep this nice and simple and say that k is just any number, but it's greater than 0. Okay, so it's not negative, it's not 0. Now, how would you integrate this? Well, there's two ways. Let's do them both. So the first way is you would rewrite the integral as 1 over k, and then you've got your integral of just 1 over x dx, like that. And everyone knows that the integral of 1 over x is the natural log of x. So this becomes 1 over k times the natural log of the absolute value of x plus c. Okay, nice, pretty simple. That's the typical way. Normally, if you've got something like, let's say it's 1 over 2x, you're probably going to take the 1/2 out. But what if you didn't? So let's look at that. So second method. So we don't take the 1 over k out, and we just leave it as 1 over kx, and we directly integrate it like that. So it's definitely going to be 1 over kx is our integral, and it's definitely going to be something times the natural log of the absolute value of kx, like this. Now, to think about what constant would have to go on the outside, we can differentiate the natural log of kx and see what we get. So when you differentiate the natural log of kx, you will get k over kx, and the k's cancel each other out, leaving you with just 1 over x. But we don't have 1 over x, we have 1 over kx. So there should be a 1 over k out here in order to account for that. Okay, so now if you differentiate this, you'll get the same thing, but you'll get this extra 1 over k out here, which will give you what we originally were trying to integrate. But of course, we need our plus c. And if we do that, you literally see, look at these two answers. They are not the same as each other, right? They're not the same because one of them is 1 over k times ln x plus c, and one of them is 1 over k times ln kx plus c. So they are clearly different things, unless k is the number 1, but that's a boring situation. Imagine that k is anything other than the number 1, any positive number. These are different things. So what's happened? Is one of them wrong? No, one of them isn't wrong, but these answers, they genuinely are different, but luckily they only differ by a constant. Okay, so the second answer can be rewritten as 1 over k times the natural log, and the absolute value of kx here, we can rewrite this as the natural log of the absolute value of k plus the natural log of the absolute value of x. Okay, so that's a rule of logarithms that we can do this. And then we've got our plus c on the end. And actually you can see 1 over k times the natural log of the absolute value of k is a constant in and of itself. So this really simplifies to 1 over k times ln modulus of x plus, and then I'm going to put this in brackets. Okay, this is a stylistic decision to put this in brackets like this, and then the c like that. Okay, so now if we compare our two answers, you can see that the first one is 1 over k ln x plus c. The other one is 1 over k ln x plus a different constant. This is still an arbitrary constant, right? An arbitrary constant doesn't have to just be c. You could rewrite it as like c plus 1 or something like that. There's no point in doing it, but you could. And it's the same thing here. We've got 1 over k times the natural log of k. That is a constant plus another arbitrary constant. So what's happened is the arbitrary constant is a different number, or it takes a different value in comparison between the two of them. With respect to each other, they take different values. And that's a big problem if you don't write plus c, because if you don't write plus c, then your two answers are literally different numbers, which is no good. But if you do write the plus c, then it means they can be the same depending on which value of c you use, what actual numerical value that it is. And this stops there from being any problems because c can kind of flex and it can kind of be whatever it needs to be in order to make it all work. But hopefully that kind of makes sense. So this is just a quick example. I've got another video. I'll leave it in the link, and I'll leave it in the description. I've got another example where I do the integral of sine x times cos x 4 different ways, and you actually get 3 different values of c. So this is a kind of another example that isn't to do with trigonometry. But yeah, check that out. Thank you for watching, and I'll see you in the next one. Cheers.